Just a few more examples to make sure we've had enough practice that this makes sense. Triangle ABC has angle A equaling 32, angle B equaling 81.8, and side A equaling 42.9. What's the measure of side C? So the beauty of trig and all of this is no matter how you draw your triangle, because of the way that we have to name things, we know that we will all draw this exact same triangle because little a has to be opposite of big A, and we fill everything in. So it looks like we could start with a law of sines problem, except initially it doesn't look like we have enough information. But never forget we can use our most basic triangle sum to find out that missing angle. So if you know two angles, it's almost an automatic to subtract from 180 to find the third one. So what I find out is that angle C is 66.2. Now I can set up my law of sines and say the sine of 66.2 over little c is equal to the sine of 32 over 42.9. Cross multiply and divide, and I end up with C being equal to 42.9 sine of 66.2 over the sine of 32. And when you go to your calculator, you end up with C being 74.1. Now let's look at this word problem. An observer is near a river and wants to calculate the distance across the river. He measures the angle between his observations of 2 points on the shore, one on his side and one on the other side, to be 28 degrees. So this is exactly what happens in surveying, highways, building, architecture, things like that. The distance between him and the point on his side of the river can be measured, and it's 300 feet. The angle formed by him, the point on his side of the river, and the point directly opposite is 128 degrees. What is the distance across the river? So here's our picture, our observer, a measurable distance, and our distance r, lowercase r, across the river, which we cannot measure. So if we start looking at what we have, I know this angle, its side opposite. I know this angle, its side opposite. Perfect scenario for a law of sine problem, which is our go-to because proportions are so easy. Cross multiply and divide, and we end up with r being 300 times the sine of 128 divided by the sine of 24. When we go to your calculator, we end up with r being 581.2 feet. Definitely would present a problem to measure across that river directly. Another word problem is trying to get the approximate length of a lake. So a surveyor is going to start at one end of the lake and walk 245 yards. He then is going to turn 110 degrees and walk 70 yards, or 270 yards, back this way. So if he was standing here facing that way, he turns the 110, which means my angle that is going to be in question is 70. How long is the lake? So this is a scenario where I have that side angle side, and it has set itself up perfectly for law of cosines. So x squared is equal to 245 squared plus 270 squared minus 2 times 245 times 270 times the cosine of 70 degrees. So I've bookended those two. So our numbers are going to be quite large. So we have x squared is equal to 72900 plus 60,025 minus 132,300, cosine of 70. Start combining. Always careful with our order of operations. So I have 13925 minus 45, 249.3. X squared is 87,675.7. Take the square root, and x is 296.1 yards. So there are your final application problems for trig. Good luck with your homework.